The new 50-megawatt power plant will operate on 8 acres of land leased by Hawaiian Electric for 35 years, with an option for an additional 10. Hawaiian Electric will build, own, and operate the plant. The project is notable for a number of reasons.
This morning, the Army and the private sector is again thinking outside of the box, working with a private industry partner, the Hawaiian Electric Company, giving them access to this property to construct a renewable energy biodiesel power plant.
This public-private partnership is really one of a kind throughout the nation, where the state, the utility, and the Army can get together to promote renewable projects using resources that the Army has, using expertise that the private sector has, and really getting the cooperation from the state to allow the permitting and allowing the sites to be built.
The many benefits include increased energy security and system resilience.
The Army was primarily interested in energy security for their base, but as the project developed, we found more and more things that this plant could satisfy. We are going to be able to build and operate this power plant on Army lands. It's about an 8-acre site, and for 35 years, essentially at no cost to us. What we're doing is we're providing the energy security guarantees to the Army, and that we will be able to restore power to the Army bases and provide power to them reliably during certain contingencies like storms or outages or attacks or things like that for the duration of this lease. And in return, that energy security guarantee that we're providing them serves as in-kind consideration in lieu of a monetary rent payment. So we don't have to pay them any money from the time that the plant is in service until the time it's decommissioned for the rent, which reduces the cost of the project and therefore benefits all of our customers.
The 50-megawatt plant is comprised of 6 modern diesel generators, which offer great flexibility.
The benefit to the average customer regarding the Schofield generating station is that it allows the increased penetration of more renewable energy in a manner that is cost effective.
So the issues we see with the renewable generation are the fluctuations that are typically caused by the change in weather patterns. So for example, the wind farms, when wind speeds ramp up or ramp down, as well as when clouds roll in and affect the penetration of the PV systems. The Schofield DGs will allow us to respond quicker as well as incrementally to those changes. Sometimes we don't know how much the wind input is going to ramp up or ramp down, as well as the PV ramp up or ramp down, and we can better match the fluctuations with these smaller quick start units.
Let's say we have 300, 400 megawatts of solar on the system and the clouds are rolling over and we start having what is effectively a loss of generation. The Schofield generating station will be able to start and be online in well under 10 minutes and could actually be at full load in that time. Therefore, the Schofield generating station is able to counter the effects of the variable generation. The Schofield plant will also have black start capabilities.
So the Schofield DGs having black start capability will help us, as it will be another unit that can jumpstart the system.
We'll be able to black start the Schofield plant and provide power directly to the Army if that is necessary, or we'll be able to bring power down towards the Waiau power plant and use it to help start up Waiau.
In addition, the generating station will use a minimum of 50% biodiesel, which will help produce cleaner energy while controlling customer costs as we continue to move toward the state's renewable energy goals.
The engines at Schofield will be very efficient. They will have a heat rate in the mid 8,000s, as 8,000 BTUs per kilowatt hour. In addition, they provide benefits to the environment by being low water usage. The only water we'll be using on the site essentially is to make some urea, which will be used for emissions controls.
Because we have the ability to bring up these engines quickly in the event of a major fluctuation or a loss of another unit, so it allows us to operate the grid more efficiently. There's kind of 2 halves of the project that we've been working in very close cooperation between power supply for the generating station and energy delivery for the new interconnection. We have a new 46 kV subtransmission line that's going to connect the power plant switchyard to Wahiawa substation, and we're going to be installing these motor-operated switches in our existing power lines in the vicinity of the Army bases which will allow us from system operations to establish this microgrid to provide power to the Army directly. And there's been a lot of really good work by Energy Delivery to put that plan together and to enable these SCADA-controlled, motor-operated switches to be installed and make sure that it's all going to work when it's called upon to do so. So, I mean, the power plant is a major part of it, but the work that's being done by Energy Delivery is critical to the success of this project.
In addition to the Schofield Generating Station, we're also working on a variety of other projects to provide additional renewable power across the state. We leave you with a list of what's in the works.